Okay, let's go. Ain't no rest for the wicked. And I've got news. As a 3D professional in the making, you do fit the bill. So, today we are going to discuss the subdivision modifier. In fact, by the end of this video, you will know everything that you need to know about the subdivision modifier. You are gonna be like an expert. Now, I do hope that you didn't just land on this video randomly and that you did watch the videos of this playlist in order because we are going to start connecting some dots here. So, number one, we have opened a fresh new copy of the free project template. As you now know, in the 3D viewport, in the top right corner, you have viewport shading modes, and right now I am in rendered mode. However, if you recall, in the video where we got introduced to the viewport shading, we kind of went between solid, material preview, and render, and we only very briefly touched about wireframe mode. However, today we're gonna come back because we need wireframe mode to understand what a subdivision modifier does. Also, in previous videos, you got introduced to the concept of geometry, and also in yet another video, you got introduced into the object interaction mode, which, to review, there are many, but the main one is object mode, where you get to select objects as whole entities. And then if you shortcut press tab, and remember that in the bottom left corner you have screencast keys, you get to enter the edit mode. So I have my mesh selected, object interaction mode, edit mode. And now I am inside the edit mode where I can interact with the individual faces, edges, and vertices that make up this geometry, this mesh, this shape. Okay, if you're feeling like a little bit lost, all I've done so far is that I've hidden all the stuff that is in the free project template I've shared with you, and I have created with the mesh primitives shortcut you learned in the previous video a new Suzanne monkey head with no materials assigned. This is just for you to learn about it, follow along. You don't have to replicate this. This is just to introduce you once and for all to the concept of geometry. So to make it super clear, when you have an object and you are in object mode, you see it as a whole. But as you press tab and enter edit mode, you start to see all the lines that define the faces and the edges. And if you remember, if you press the shortcuts 1, 2, and 3, you get to highlight the vertices, edges, and faces. Now, you could be in object mode and you could go into wireframe shading and you would have access to a view mode that provides you with similar information. So in wireframe mode, at a glance, you can get a sense of the density of a mesh. Now, density is a technical description that refers to the fact that if you have an object with not too many faces, that is considered a low density. And a keyword that you might have heard before is low poly. In fact, there are plenty of low poly games, especially on mobile. Guess what? Because mobile phones do not have a lot of computing powers. And so if you have not a whole lot of poly or polygons that you need to render out in your video game, that runs smoothly. Now, what you're looking at is the basic version of Suzanne, which of course is a low poly because it comes from the primitive mesh objects list. And as the name suggests, primitives are basic things, building blocks. They are all low poly. Now, what the subdivision surface modifier allows you to do is increasing the density of a mesh. It allows you to subdivide the faces of a mesh so that it becomes more dense. However, it also allows you to do that in a very special way. Now, in edit mode, what you could do is to press A as in all to select all the faces within this object, and then right click and subdivide. And that would increase the density of the mesh. But if you notice, what has happened is that every single face that was existing before got subdivided, but it remained kind of blocky, kind of flat. And also, this is like permanent. Now, this is the thing you have. So if you were to do a whole lot of other things, like a whole lot of other commands, eventually you could not undo and undo your commands until you go back to this point and cancel this commitment. No, it's done. It's forever. Now, luckily, we have a much smarter way to go about this, and that is to use modifiers, to which you got introduced in the previous video. Now, the number one most popular modifier is the subdivision surface, which, having a mesh selected, you can go to this branch icon for the modifiers, add modifier, generate subdivision surface. And now look at that, it got smoother. So we have achieved two things here. One, we have subdivided the mesh, just like I just showed you before with the subdivide command, but rather than just subdividing it, it kind of created a more curved surface where the new subdivision points have appeared along a curvature that is interpolated between the two pre-existing points. So to explain a little bit better, if we had this point and this point, right, now a straight edge is running through it. If I were to just subdivide, a point would appear here. However, with the subdivision surface, the new point that has appeared is recreating the surface with a higher curvature resolution. Now it's smoother. Now the second super important thing that we have achieved is that all of this is non-destructive. This is another technical word. It means you're not committed to it. You can turn it off and on whenever you want. Now, as you have noticed, there are quite a lot of options here, although not as many as in other modifiers, but nevertheless, we are going to go through all of them. So let's start at the top. We have a series of icons. Now notice that right now I am in edit mode. And so when you toggle this one, what is happening is that within the edit mode, this allows you to sort of preview the change that the modifier is actually making. This one allows you to toggle between what the original mesh looks like and what the mesh with the applied modifier looks like, while having the old cage, the old wireframe highlighted. Whereas if you have also this one selected, it kind of shrinks down to the new one. Back into object mode now, this icon allows you to see the preview of the modifier inside the 3D viewport. Okay, so this allows you to toggle on and off a visualization of the applied modifier, but this is relevant only to the 3D viewport. For the actual render, we have the icon to the right, which, if you notice, is the exact same icon that we have in the outliner. And by now, you know that this camera icon refers to things that have to do with the final output with the final render. Now there's a little icon to the right that gives you some extra options. The first one is apply, and this one allows you to actually commit to the changes created by the modifier. Okay, so right now we are in a non-destructive workflow, meaning you can go back and forth with it as many times as you want to, but if you apply, then that's it. It's committed. Why would you want to apply the change if the whole point is to be non-destructive? Well, at some point you might hop from Blender to another software like Unreal Engine, and so you might have to export your files, your 3D models, your assets. Before you do that, you have to apply the modifiers. Otherwise, when you go into the other software, you won't have all of this manipulation that the modifiers have done. You have to commit to that change before you step outside Blender. Now, the next few options allow you to duplicate or move the order of the modifiers. And that's because you can have as many modifiers as you want, and the order in which they appear matters. So there is a hierarchy. So to give you an example, I could duplicate this, and now I have another subdivision. However, the second subdivision is not starting to make modification from the raw mesh. It's starting to make modification based on the result from the previous modifier, the one above. And to reiterate, because this is a non-destructive workflow, if you were to toggle off the previous one in the stack, this one, which is still active, now is operating based on the result of the one above, but because the one above is off, it's yielding the same exact result as if we were starting from the basic mesh. Now, I am going to keep the second one right there, but I'm gonna turn it off just for a minute because I am going to use it later to demonstrate some other aspects. Okay, so there are two possible subdivision schemes. The Catmull-Clark is the one that will interpolate between the existing point and make the mesh not only denser, not only higher poly, but will also create this curvature effect. These numbers refer to the iterations with which is applied. And once again, this one pertains to the viewport and this one to the render. Now, as you go up, it's gonna become smoother and smoother and smoother, okay? But don't go too high, don't go too crazy. Like 5 is really, really high already. I'm going to use a plane to demonstrate this. When you subdivide things, the subdivision, it's not going to progress in a linear fashion. So suppose that this plane is an example for a single face on your mesh, a single quad. The moment you subdivide it, regardless of what scheme you're using, Catmull-Clark or simple, you're going to go from one face to 4 faces. So now it's 4 times more expensive to render. If you do that, again, a second iteration, which is what's happening when you go up a level in the sliders in the modifier, this is going to happen. So you subdivide again, so you subdivide each face again, and now you have 4 faces for each face that you had before, which makes 4 times 4, and now it's 16. So in 2 steps, you went from 1 face to 16 faces. So as you can guess, this thing can skyrocket pretty quickly. And as long as you're dealing with a very simple mesh, you will get away with it. But suppose that you had an already somewhat complex, somewhat dense mesh, you could get in trouble real quickly. And then you're gonna see your computer like freeze because it's trying to calculate all of these changes. So back to our modifier, now you understand what these numbers mean. Now the difference between Catmull-Clark and simple is that simple applies the exact same operation that you can manually apply with the subdivide command we just saw in the edit mode, but it remains non-destructive, whereas the Catmull-Clark does the same operation of subdivision, but also applies this sort of smoothing interpolation. And now we'll finally understand why the wireframe is important in this conversation, and that is the optimal display option. The optimal display option, when you toggle it, allows you to see or not the changes that you are making with the modifier. So if you have it off, it's gonna show you the subdivision that you have created. And as you can see, already at level 2, we have a whole lot of geometry. But when you work, in most cases, you do not want this turned off. You want the optimal display on, which will show you a version of the mesh that features the curvature of the applied Catmull-Clark, but in terms of wireframe, in terms of lines, you will only see the density of the original one, although they will appear curved. Okay, so this is probably the best way of demonstrating why this matters. So most cases you want the optimal display on, because otherwise in a scene where you have a whole lot of things that are using the modifier, a lot of meshes that are high density, well, things can start to look like this, where it all appears to be solid black almost, and you can't tell the relevant information anymore. So most cases you're gonna keep this on. In fact, it is on by default. And now looking at the advanced stuff, use limit surface, you won't touch it. But just to know what it does, it is calculating the position of the new vertices from the Catmull-Clark operation as if you were to do infinite numbers of subdivisions. So you can kind of see that it slightly changes between the actual thing with 1 or 2 level of subdivision and a more sort of precise way. Same with the quality. This is the quality of the operation, the computation that your machine is making to achieve this result. You will almost never change it away from 3, which is the default value. Next up, UV Smooth. As you can see, you have several options. Very rarely you might have to change this, but once again, the default is good in 99% of the cases. All that this does, it changes what points the Catmull-Clark operation is considering, and so it allows you to kind of like have the best of both worlds sometimes between Catmull-Clark and simple, where some parts of the mesh will be curved and others, like the corners, will just stay fixed. Now to make this super clear, here I have a simple plane that has been subdivided once manually, and then I have applied 2 levels of Catmull-Clark subdivision. And as you can see, although it is a plane and I have elevated this middle section to make it curve a little bit like this. As you can see, the corners are getting rounded. And if I were to go up and up and up, they will start to get progressively more rounded. They get smoothed. Now, if you were to change those options to, say, keep boundaries and keep corners, that would allow you to keep the sharp corners while also getting the good curvature, which you could not do with just a simple operation, because as you can see, if you were to select that, it would just keep a straight, sharp edge everywhere. Okay, so to cover the last two options, let me tell you right away, not once in your life you're likely to check in on custom normals. You just won't. It's just so unlikely. But the use crease, it's something worth knowing. So, to understand that, you need to know what's a crease. A crease is a more advanced modeling technique. And since we have not even really started 3D modeling, I will just briefly show you this just so it makes sense. But what you can do is, given an edge, you can alter some of its properties. And if you're in edit mode and you go to the N panel, which now you know, and the item tab, which now also you know, there are these options below that we have not covered yet, but this allows you to manipulate the edge data. And if you were to create a crease between these two edges, you would be able to keep them sharp. And so as you can see, now I have one corner that is super sharp and the others are kind of rounded. And also it's a little bit difficult to see, but the edges that have a crease applied to it are turning into this kind of magenta color. Now, as the name says, all of these are kind of advanced features that you will only need in very extreme cases, but I promised you that you would know absolutely anything and everything about this modifier, so here we are. Now, before we wrap this up, the one remaining thing that you need to know, and that we already mentioned, is that modifiers have hierarchy. And so the order in which the operations are executed matters. And that's why I kept the second subdivision modifier over there to demonstrate this point. Suppose that you have a mesh like the default Suzanne had, which is low poly. And then you go through a simple subdivision 2 times. And now you have this kind of mesh that is higher density but has not been interpolated, and so it's retaining its edgy look. If you were to now reactivate the second modifier but apply a Catmull-Clark operation to it, a smoothing interpolation to it at the second level once again, well, first of all, you will notice that you have a whole lot of faces right now. But also, you should notice that it has retained the edgy look, because the second operation, it's starting from the result of the previous modifier, which is the one above. Now I'm gonna click on these arrows to the left to minimize the modifiers, and I invite you to experiment with it to get a sense of how these things work. But here are a couple of examples. Number one, again, because this is non-destructive, if you were to change this to Catmull-Clark, now you would see the operation result of 2 consecutive level 2 operation at Catmull-Clark, which would produce a super smooth surface. which would also be the same as having just one modifier but at a level 4, same exact result. And if we go back to the previous example where we had a simple scheme level 2 and then a Catmull-Clark scheme at level 2, like I said, minimize this, go to this right icon and try to swap them. And you will see that the result changes because once again, the order in which the operation happens matters. So what's happening right now is that we are taking our original mesh, we are smoothing it a little bit, and then we are doing a hard subdivision, simple scheme subdivision, which, as you notice, has increased the density quite a lot, but it remained kind of edgy. And I know it's difficult to see, but it is definitely a different result as if it were like this. All right. So that wraps it up. Officially, now you are an expert in the subdivision modifier. You know everything you need to know and more. You are good to go forever. And in the future, when we cover more advanced stuff, you will be, aha, I remember this. Now, I hope you have poked around a little bit in the free project template that I've shared with you, because here and there I am using modifiers, and if you have not done so yet, I do invite you to explore the scene, see if you can make out what modifiers I'm using, what they do. Now you definitely know about the subdivision modifier that is applied to the Suzanne monkey head, so you'll know 100% what's happening and why. And the remaining modifiers that are featured in this project template are there because in due time we will cover them too. And so as we move forward with our learning path, eventually every now and then we will come back to this one file to sort of review things in an environment that is simple enough, but hopefully also exciting. So that was a whole lot, and we are officially done with this video. I'll see you in the next one.